In this video, we're going to look at the first question of exercise 9.1. So we're looking at the wave function here. So we're solving the following pairs of equations where k is greater than 0 and your alpha lies between 0 and 360. So just writing the two equations on top of each other, we've got k sine of your alpha equals 1 and k cos alpha equals 1 as well. Now, process is the same every single time here. We're going to square all parts of both of these equations because I know, thinking ahead, that I will be able to simplify the situation and get a value for k. So if I square each part of this, we square the k squared, sine squared alpha equals 1 squared is 1. Same with the second one, k squared cos squared alpha equals 1 squared is 1. So just making sure to square each term there. Now we've got a simultaneous equation that we are going to add both of the equations together, again knowing that that will help me out to find k. So the first equation, k squared sine squared alpha plus your second equation, k squared cos squared alpha equals, and 1 plus 1 gives you 2. So on the left hand side of the equal sign you've added those two terms, and the right hand side of the equal sign you've added those two terms. Now, highest common factor, we've got a k squared that we can take out. And then you've got sine squared alpha plus cos squared alpha equals 2. And recognizing from your Nat 5 trig identities that sine squared alpha plus cos squared alpha equals 1. So you've got k squared times by 1, or just k squared, anything times by 1 is itself, equals 2. To get rid of your squared, you square root. K equals plus or minus the square root of 2. So at higher, you're always thinking about your two possible values for k, plus or minus. But it did tell us in the question that k is greater than 0, so k equals root 2 as k is greater than 0. And you'll be doing this so many times through with all of these questions that it's going to become a really nice repetitive process there. Okay, then from here, I'm going to take our first equation that we started off with. So taking this down here, instead of writing k sine alpha equals 1, I can now put in root 2. So root 2 sine alpha equals 1. And we've got an equation solving for our angle. Sine of our angle equals 1 over root 2. Hopefully recognizing that that is one of your exact values. So your acute angle is your inverse sine, if you want to think about it like that, of 1 over root 2. You could check in your calculator if you need, but you should know from your exact values. Just check your table that hopefully you've written out and you have handy. That would be your angle of 45 degrees. Sine of 45 gives you 1 over root 2. And then, as this is a positive value, let's draw our sine graph to find our solutions. So it's a sine graph going there. 1 over root 2 is positive, so we're going to get our two answers here and here. So that distance in here is 45. That distance in here is 45. So you're going to have your two solutions. X equals 45 degrees and x equals 180. Take away 45 is 135 degrees. So those are your two solutions for that one. Then for your second equation, root 2 cos alpha equals 1. Cos alpha equals 1 over root 2. Again, it's an exact value here. Your related acute angle is your inverse cos of 1 over root 2. What angle gives us 1 over root 2 if we're in cos? And it's 45 degrees as well for that one. Again, drawing out a graph to find our solutions, we will get cosine graph starts at 1, goes down, comes up. 1 over root 2, it's positive, so we're going to have this answer here and this answer here. So you've got a distance of 45 from here and distance of 45 here. So your two answers for this are going to be x equals 45 degrees and 360 take away 45 degrees is 315 degrees. And at this stage, you look at which of these angles you have in common. Well, for both of these equations, for it to satisfy both of them, our answer in common is x equals 45 degrees. Oh, it shouldn't be x, it should be alpha. I'll put it in our actual answer. So, our two answers, finding our two unknowns, our alpha, so we've got it clear in the final answer, equals 45 degrees, and our k equals root 2. And that's you done.